everyone, and welcome to today's explainer. We're about to take a walk across the automation bridge. Now, if you've been working in networking for a while, you absolutely know the pain of the manual drill, right? Logging into devices one by single one, typing out the exact same commands, and just mindlessly copying outputs into spreadsheets. Well, today, we are officially moving away from that manual CLI drudgery. We're stepping confidently into the highly scalable, incredibly powerful world of Python. Let's get into it. We've got a fantastic roadmap for this explainer. 1. Shifting our mindset and using the sandbox. 2. Organizing network data. 3. Adding logic and scale. 4. Building reusable scripts. And finally, 5. Supercharging our workflows with external packages.
But look, before we start typing out any code, we really need to address the elephant in the room. A lot of network engineers immediately ask, wait, do I need to become a full-blown software developer to do this? And the resounding answer here is no, absolutely not. You aren't trying to build full-stack web apps or crazy complex software architectures. You just need to understand how to write and use small scripts to replace your repetitive CLI work. That is the entire goal.
Okay, Section 1, Mindset Shift and the Sandbox. Let's establish exactly where your journey should begin. When you're just starting out, you might naturally be terrified of breaking something on your production network. To avoid that completely, we use what's known as the interpreter-first method. Basically, instead of writing a massive script all at once, you just utilize the interactive Python shell as a safe little sandbox. You can jump in there to quickly test your string parsing for interface names, or maybe isolate a specific IP address. And only once you know your logic works perfectly do you actually commit it to a full, reusable script file. It's a total game changer for building confidence.
Moving right along to Section 2. Organizing network data. Let's look at how Python actually understands the info you pull from your routers.
The crucial thing to grasp here is that basic programming concepts map directly to your daily network reality. For instance, strings help you build configuration commands or clean up CLI output. Booleans, they just give you a simple true or false for whether a device is actually reachable. Lists are perfect for keeping an ordered inventory of your interfaces, while dictionaries store named facts, things like the vendor name or the OS version. It's basically taking chaotic text output and turning it into structured information we can actually use.
And speaking of structured information, you'll notice a massive difference between lists and dictionaries. While lists rely on somewhat confusing numerical indexes that always start at 0, meaning you constantly have to remember what item number 3 actually represents, dictionaries use crystal-clear human-readable keys. I mean, calling device for hostname makes perfect sense the very second you look at it, right?
Really, just think of a dictionary as a digital filing cabinet for your Python scripts. Just like a physical filing cabinet uses clearly labeled folders, dictionaries let you pull the exact data you need instantly. Whether it's a hostname, a vendor, or an IP, there is absolutely no unnecessary searching through a messy stack of CLI text. You just ask the dictionary for the key, and boom, it hands you the value.
Of course, out in the real world, sometimes you still have to deal with raw, unstructured text. That's exactly where string methods come into play. You're going to rely heavily on these to wrangle messy output. You can use lower to normalize text, strip to wash away annoying white spaces, and split to break IP octets apart. You can use start with tag to quickly find your Ethernet interfaces, and join to smoothly stitch commands together. Oh, and you can even use format or f-strings to dynamically inject variables right into your commands. It's like having a multi-tool for text.
All right, Section 3, adding logic and scale. This is where we make our scripts smart.
We bring in logic through conditionals and containment checks. By using your basic if, elif, and else statements, your script can verify conditions before it does anything rash. For example, it can check a Boolean to ensure a device is actually reachable before trying to connect. Or, by using containment checks, your script instantly knows if an interface starts with Ethernet, or if it should push an iOS command because the vendor is definitely Cisco. Now, a conditional makes a really smart decision for one device, but a loop scales that decision up. Loops allow us to iterate over dictionaries of devices, or lists of VLANs and interfaces. So instead of doing things one by one, you can run the exact same formatting or validation against 20, 50, or 100 switches instantly. No copying, no pasting, no writing the code twice. Which brings us nicely to Section 4, building reusable scripts. It is time to graduate from the sandbox. To build true automation, we use 3 main building blocks. First up,
Functions. You wrap your loop and conditional logic into a function so you can reuse it whenever you need to generate VLAN configs. Next, files. Your script can easily read configuration snippets from a local file, like a VLANs.cfg, and then write the output logs straight back to a report file. And finally, modules. You can brilliantly organize your code by importing your custom functions into one central execution script, maybe called push.py. Do this and you eliminate duplicate code and create a workflow that runs flawlessly every single time.
Now, a massive piece of making scripts reusable is leveraging variables. Instead of hard coding or typing out target IPs every single time, we assign them to structured variables within our script. Think about it. If an IP changes down the line, you don't have to hunt through hundreds of lines of code. You just update the variable in one single place. Easy. You can actually take this a step further and pass command line arguments directly into your script right when you run it. Imagine just opening your terminal and typing python send command.py, dropping in your target IP like 10.1.10.10, and adding show version. You are passing the IP, the username, and the command dynamically, executing complex queries without ever once touching the actual device CLI. Finally, we reach Section 5, Supercharging with Packages. This is where we bring in the heavy artillery. Because listen, you absolutely do not have to write the complex backend rules for SSH connections or data parsing entirely yourself. You can use Python's package manager, pip, preferably inside a virtual environment, to install incredible community libraries. For example, Netmiko handles secure SSH-based automation across a massive variety of vendors. And tools like NAPALM allow you to gather facts and ensure multi-vendor compliance by returning data as beautifully structured Python dictionaries rather than a wall of messy text. They do the heaviest lifting for you. Network expert Orhan Ergun really hits the nail on the head with this quote. Automation and networking just isn't optional anymore. The old days of manually typing configurations into terminal windows, they're fading fast. They're actively being replaced by these structured, highly scalable Python workflows that save you hours of time and completely eliminate human error. So the building blocks are firmly in your hands now. Remember, you do not need to be a software developer to pull this off. You just need to solve your own bottlenecks using small scripts. So take these concepts, open up your Python interpreter, and think about the absolute most tedious, repetitive task you do every single week. What are you going to automate first? Go start building your bridge today. Thanks so much for joining me on this explainer, and I'll catch you on the next one.